the nth term of the arithmetic progression. In this one, this is the problem taking from an exercise 1.1 10th standard arithmetic progression. The first problem. In the first main, they are asked to find out does the list of numbers involved make an arithmetic progression or not. So now we have to convert this into a series of numbers. Here they given that the taxi fare after each kilometer, when the fare is rupees 15 for the first kilometer and rupees 8 for each additional kilometer. So here they given that the taxi fare of the for first kilometer is rupees 15. That means here we have to take the first term, that is A1 is equal to, it is of rupees 15, and for each additional kilometer means for each additional kilometer we have to add this rupees 8 for that one. That means that is D is equal to 8 here we have to take. So then for first term we have to write this as this is A1 and A2, A3, A4. For getting these numbers we have to write the terms here. For the first term we have to take this as A, and the second term taken as A plus D, and the third term taken as A plus 2D, and the fourth term taken as A plus 3D, and so on. These are the terms of the arithmetic progression. Now we have to take this A as 15, that is the first term. So we write this as 15, and for each additional kilometer we have to add 8. So for next kilometer, so that means the 15 rupees plus 8 kilometer. This is for the first kilometer and this is for the second kilometer. So for the third term, that means for the third kilometer we have to add 15 plus, that is 2 times of D, that means 2 into 8. And for the fourth term we have to add the first kilometer and then 3 into, that is the next additional kilometer, that gives you this term. So we have to observe here, this gives you 15 and 15 plus 8, that means that gives you 23, and then this gives you 8 into 2, 16, 16 plus 15, 31 we get, and 8 3s are 24, 24 plus 15, that is 39, and so on. We get the series of number like this. You observe the difference of any two consecutive numbers is, that is constant. That means 23 minus 15, that gives you 8. 31 minus 23, that also gives you 8. You observe here, 23 minus 15, that is equal to 8, and 31 minus 23, that is also equal to 8, and 39 minus 31, that is also equal to 8. Here the series of numbers are the difference of the common difference of these two numbers is constant. Therefore the series, this number is an arithmetic progression. Thus this problem gives the series of the arithmetic progression. So this is the solution of this problem. Okay, thank you. This is the second problem. The problem is that the amount of air present in the cylinder when a vacuum pump removes 1/4 of the air remaining in the cylinder at a time. So for the air present in the cylinder we have to take, let the initial volume of the air present in the cylinder be V. Here V is the first term, therefore we taken A1 as the V. For finding A2, we have to remove 1/4 of the air present in the cylinder. So for that, this is the first term, we have to remove 1/4 of the volume of the present in the cylinder, that means 1/4 of V. So therefore we have to simplify this like this. We taken as the 4 as the LCM here. But there is no denominator in the first term, we have to multiply 4 to the V, that gives you 4V minus, here the denominator is the LCM, we have to write the numerator as it is. So therefore we get 4v minus 1v, that becomes 3v divided by 4. So this is the second term here we get. For finding the third term, A3 is equal to the air in the cylinder now is of 3v divided by 4. We have to subtract 1/4 of this volume. So we have to subtract 1/4 of that is air in the cylinder. So we have to take 3v, we have to subtract the 1/4 of this one. That means into 1/4 gives you 1/4 of the volume of the cylinder that is remains in the cylinder. So this gives you 3v divided by 4 minus 3 into v, 3v into 1 is 3v divided by 4 into 4, that gives you 16. So this implies here 4 and 16 are there. We have to take the LCM of that one, 4 and 16, 4 ones are, 4 fours are. So then we have to multiply all the terms, 4 into 1 into 4, that is LCM of that problem is 16. So we have to take the LCM here is 16. So the first denominator is 4, we have to divide the LCM by 4. 4 fours are 16, so that 4 times it was divided, we have to multiply this one, 4 threes are 12v minus, then 16 is divided by this LCM, 16 ones are 16, that is 1 into 3v, that gives you 3v. So that gives you 12v minus 3v, that gives you 9v divided by 16. This is the third term. So now we write the terms of the AP. We get first term is v and second term is 3v divided by 4 and the third term is 9v divided by 16. These are the terms of the AP, first term, second term, third term. So now we have to find out the difference of these terms. That means we have to subtract the first term by the second term. 3v divided by 4 minus v. How can we get? That is 3v minus here 4 is the LCM, 4 into v, 4v, you get the difference of this one is minus v divided by 4, and then you have to subtract these two, take the difference of these two terms. That means 9v divided by 16 minus 3v divided by 4. Here also we have to taking the LCM as 16, that means 16 ones are 16, 1 into 9, 9v minus 4 fours are 16, 4 threes are 12v. Here we get by subtracting these two terms 12v minus 9v, that gives you minus 3v divided by 16. Here you observe the common difference is different. There is no constant common difference of the terms of this AP. So we say that this problem, that is the amount of air present in the cylinder, that problem is not under AP. So this is the solution of the problem. So thank you students. We have to solve the third problem in the next video.